Welcome to the video lecture series on Introduction to Computer Networks. Today's topic is going to be the Internet Protocol. So, what is the Internet Protocol? In short, it's commonly known as the IP protocol, and it's similar to the postal system that we can imagine of working in everyday real life. The basic idea is in a postal system, it ensures delivery of messages and letters from a source to a destination, even if there are no direct connections between the source and the destination. So that is what the Internet Protocol, that is IP, ensures. That is the delivery of packets from a source to a destination across multiple networks, even though they are not directly connected. So the IP ensures or specifies certain packet formats. There are multiple different kinds of packets which are supported by IP, and the formal specification of IP defines the exact format of these packets. There are also many different schemes for addressing hosts that we use based on IP. The most common is the IP address, which I believe should be something that is common to you. So the IP address is a part of the IP protocol. And finally, IP specifies how hosts and routers should process and route packets. That means that when a source is trying to send out a packet, IP specifies what it should look like, and in the process of being delivered to the destination, there are intermediate routers which are also specified according to IP how these packets should be processed so that they are routed to the required paths. One important thing that IP provides is the bridging of lower level protocols, that is the data link layer, and the upper layer protocols, which is the transport layer. So it is something which sits in the middle in layer 3. And if you try to have a quick recall of the different TCP/IP layers, according to the TCP/IP model, the lowest layer, that is the physical layer, is responsible for receiving and transmitting bits, the electrical signals. It could be across wires or radio frequencies. Layer 2, that is the link layer, works with MAC addresses and ensures delivery of packets which are delivery of frames which are directly connected with the help of MAC addresses. In layer 3, we have the network layer. The predominant protocol for the network layer is IP, that is the Internet Protocol, and it's responsible for creating the route for packets across multiple networks, and they work with what we call as IP addresses, which are virtual addresses assigned to interfaces for hosts which reside in a certain network. Going higher, we have the transport layer, something we also looked at, which we looked at earlier as well. The predominant protocols for the transport layer are TCP and UDP. One is more reliable than the other. TCP is more reliable, however, it's slower. UDP is less reliable, but it is faster. And the idea of transport layer is to ensure delivery of messages across two hosts to specific applications which are running on these hosts. And finally, the application layer is working in the topmost layer and requires the interpretation of the messages which it receives from the transport layer to be presentable to the users. So if you look at how the TCP/IP model is generated, the IP sits right in the middle in the network layer. So in the top, we have the transport layer and the application layer, and below the network layer we have the data link layer and the physical layer. And there are multiple protocols which is supported in data link and physical layers, as well as the transport and application layers. However, one thing that the IP ensures is that it allows the bridging of the upper layer protocols with the lower layer protocols through IP, which is one specific protocol, and everything that needs to function in a network needs to support IP so that it can perform its required actions. So in a way, we say that this is an hourglass model, and IP sits at the waist of the internet hourglass model and focuses more on the end-to-end delivery. It does not really care what it receives from the upper layers or what it passes on to the lower layers, but just the fact that the end source and destination hosts are able to receive and transmit the packets. So in terms of IP, that is the IP protocol in the network layer, it allows logical addressing of network hosts through the use of IP addresses, and it allows end-to-end delivery of packets. However, the way that the delivery is facilitated in IP works in three different modes. First, the most common one probably is the unicast mode, where packet is being sent from one specific host to another specific host. So it's just one-to-one delivery. The second kind of delivery is what we say is a broadcast. That means there is a one single source, but multiple destinations, and all of these receive the same packet at the same time. Well, they don't receive at the same time, they are sent at the same time, but they may receive it at different times based on the route that each packet takes. But however, it is the same packet that is sent to all the destination hosts. The third kind, which is probably a combination of unicast and broadcast. This is something that we call multicast. And here, what it does is that there is one single source, but there are a set of selected destinations where the packets will be sent. A very common example for this would be, for example, IPTV, where the single source is, let's say, Netflix, and there are multiple subscribers who are receiving that same broadcast. However, in common terminology, we call this a broadcast, but in terms of network terminology, this is a multicast, because the stream of Netflix video is sent to specific hosts over the internet. So that means they are selected based on some subscription services, etc. And only those hosts will be able to receive the packets. So to summarize again, IP packet delivery works in three different modes. Unicast is one-to-one. Broadcast is where one single source is sending out to all the other nodes. And then we have multicast, where you can select a set of destinations and send it out from a single source to those selected destinations. So it's one-to-many delivery. So going forward, the next part, that is part 2 of this video lecture, will cover a lot of IP addressing stuff. But however, I would like to make sure that all of you are well aware of the number format conversions. Very specifically, we'll be using a lot of decimal to binary and binary to decimal conversions. So make sure that you go back and review the chapter on data representation. It's not going to be a bad idea if you would like to practice a few conversions from decimal to binary and binary to decimal. And most of the times we will be working with 8-bit binary numbers and converting it back and forth from decimal to binary and binary to decimal. So make sure that you are well versed in that process, and then you can proceed to part 2 of the video lecture.